We may be on the brink of drastic climate change. Global warming and climate change caused by human activity have been talked about for decades. One of the gases, apart from CO2, which warms our climate, is methane. And it was in this context that scientists noticed something disturbing in 2006, the reasons for which they were unable to explain for years. Large amounts of methane leaking into the atmosphere could trigger drastic climate change, according to a new study published in the journal Global Biogeochemical Cycles. Scholars are talking here not about changes we are experiencing now, but about changes that ended entire ice ages, such as replacing the icy tundra with tropical savanna. Scientists first detected a strange increase in methane emissions in 2006, but until now it was not clear what was causing it. Methane as a greenhouse gas is extremely efficient. Its sources are both human activities, industry, agriculture, landfills, and natural processes. Anthropogenic emissions of this gas into the atmosphere began to increase dramatically in the 1980s, then stabilized in the 1990s. However, in the first decade of the 21st century, something unexpected happened. Well, in 2006, scientists noticed a sudden increase in methane emissions. However, this was not accompanied by any changes in human activity significant enough to be blamed. Even worse, in 2013 this trend was observed to intensify. And in 2020 the increase in the rate of methane emissions was the highest in history. This issue has puzzled scientists. Finally found the culprit. It turned out to be tropical wetlands, especially those located in Africa. The source of methane, as researchers suspect, in this case are the decomposition processes taking place in them. And again, the man is to blame. Previous anthropogenic climate changes have led to such weather shifts, which in turn have contributed to an increase in the area of wetlands and the growth of more plants in these areas. In the context of the above information, the key question is what may be the consequences of this. Unfortunately, scientists do not have good news. Such situations have already happened in the past of the Earth and have always been accompanied by drastic climatic changes, such as the transition from glaciation to interglacial. At the same time, it makes us realize how significant, in terms of potential, the phenomenon we are dealing with here. In general, 3 phases led to the end of the glacial period. A gradual increase in methane and CO2 levels, which over several thousand years became the cause of global warming. A rapid increase in temperature caused by significantly increased methane emissions and a gradual stabilization lasting the next several thousand years. The middle phase is crucial here, because the current situation in the context of tropical wetlands resembles it. And most importantly, on the scale of the age of the Earth, it lasts really short, because it can only be several decades. And considering that the increase in the rate of methane emissions began to be observed in 2006, it could mean that we have already had 16 years of this process behind us. Of course, we do not currently live in an ice age, at the end of which the tundra could become a savanna. It is therefore extremely difficult to predict what exactly may happen in the next decades. Nevertheless, we should bear in mind the need to further reduce methane emissions to the atmosphere from as many sources as possible. Scientists have recorded how a virus attacks a cell. With extremely sensitive instruments, scientists have recorded for the first time how a virus attacks a cell. The footage shows the intruder tracking down the target and looking for an entry point, eventually escaping. The recording lasts 2.5 minutes. It shows a virus, thousands of times smaller than a grain of sand, moving among tightly packed human intestinal cells. A description of the new technique for recording the behavior of pathogens has been published in the journal Nature Methods. The video shows how the virus makes contact with the cell for a brief moment, glides over its surface, but does not stick to it, and then escapes. If this had been a real home break-in, this would have been the moment the burglar hadn't broken the window yet, says Courtney Johnson. Johnson is part of a Duke University team led by Kevin Welsher. Together with Jack Excel and colleagues, they came up with a way to capture a real-time 3D image of viruses as they approach their cell victims. We inhale and ingest millions of viruses every day. Most of them are harmless, but some, such as influenza viruses or COVID-19, can make us sick. Infection begins when the virus binds to a cell and destroys it to make copies of itself. But before that can happen, the virus must first reach the cell. This often means breaking through the protective layer of cells and mucus that covers the airways and intestines. It is one of the body's first lines of defense against infection. Researchers wanted to understand how viruses breach this first line of defense. These critical moments before the onset of infection were for a long time difficult, if not impossible, to observe with existing microscopic methods. Observations are difficult because viruses move much faster than the cells themselves. They are also hundreds of times smaller than their cellular victims. That's why it's such a difficult problem, says Johnson. It's like trying to take a picture of a man standing in front of a skyscraper. You can't take in the whole skyscraper and see the details of the person standing in front of it in one photograph, he explains. So the team developed a new method called 3D tracking and imaging microscopy, 3D TRIM, which essentially combines two microscopes in one. The first microscope focuses on a fast-moving virus, sweeping its laser tens of thousands of times a second to calculate and update its position. A second microscope takes three-dimensional images of the cells surrounding the virus. The effect is similar to navigation from Google Maps. Not only does it show your current location as you drive, but it also shows landmarks and the general layout of the terrain in 3D, explains Welsher. Still, many problems remain unresolved. To be able to track the virus, a special fluorescent label must be attached to it, which only works for a few minutes. Researchers also cannot yet observe the full path of infection, from the respiratory tract to the cell. However, Welsher hopes that in the future the technique will develop and allow viruses to be tracked in more realistic conditions.